Yeah, yeah. Okay.
So what did we decide that we'll talk about graphs or what?
No, I think maybe we can leave graphs for next week, just so that everybody has
Okay.
a bit of time to research. And yeah, we can start with the challenges, the ones that you wanted to improve.
Okay, great. So I'll go ahead and share my screen here.
Yeah.
Okay. So as you can see, this particular solution took quite a while to actually run. Even though the code isn't that big, there's not a lot of lines here. So I do have other solutions that did whittle this down to quite, like I said, like 600 something milliseconds. But the point is to all talk about how to make it more efficient. So any other suggestions, any ideas here would be great. Let's see, I will actually open a new window and we can make sure things still work here. Algorithms. Yeah, give me a second to open up the algorithms that I have. Get algorithms. Okay, and just happened. This one is single number. All right, so now I can share. All right, so we're getting 1104. So anybody, let's talk. Any ideas on how to make this a little bit more efficient?
Could you just explain what the problem is and how you're doing it?
Absolutely. So, okay. It's been a while since I've actually looked at this, so might have to look at it together, but we have this single number method here that returns if it's only one number in the array, if the num's length is one. Um, Otherwise, it just whittles it down to first the unique digits and then let's see, returns that digit if there's only one of them. So it looks like it's taking an array and finding out which number is only repeated one time. So twos are ignored, we have the one. One because there's only one, zero is only one, four is only one. Now, if I don't know, actually, they didn't try this, but if I were to put another four in here, we might not get anything back. It returns the array of four. But that wasn't part of the actual challenge, so I didn't bother worrying about if there was no single digit numbers. But that's the purpose of this method, to find which numbers only represented one time.
So just at line 41, nums.unique, what does this do again?
This takes the array and only finds it only includes the ones that are unique to the array. So actually it only looks at 2 and 1. And then when we come in here, it just checks the 2. If nums.count of 2 equals 1, it returns 2. But when it checks the whole array, it finds there's more than one 2, so it goes to the next one. Then it says, okay, number 1, does the array of nums how many number 1s are in there? If it's only 1, then it returns that 1. So this takes the whole array and only returns basically the set.
I mean, I don't know. It's very short. I'm thinking, okay, so maybe what if you use sets?
Okay, tell me what you want me to do here. Exactly.
Instead of num, like how do you know how fast this one is in order to compare it to like a new
Well,
solution?
right here, I've already submitted this to LeetCode and I have the runtime and the memory usage. And like I said, I do have other submissions here. So see, I've got three other submissions. Single number, I managed to work from 2884 actually to 64 milliseconds. I've got a 184 and an 1164. So clearly we can make this way more efficient.
Okay. Okay.
And I don't
so
believe I used a set to do so, but we can certainly try it.
Where's the inefficiency coming from in this code?
Well, I don't want to give too many answers in that regard. So what do you think one of the possible ways it is?
I think it's going to be from one of the methods that is included in Ruby by default. So you've got .unique, and then you're looking through that. To be honest, I'm not sure. No, I'm not sure.
Okay, so let's try something. What do you want? How do you want to write this? And anybody else, speak up if you have any ideas here.
Yeah, I also think that nums unique is the heaviest one here, but
okay.
But how can we make it, faster? I have no idea.
Okay, so you said the nums.unique. It basically gets you the just the numbers without any duplicates, which is the same thing that a set would do. Can you create a set and basically look through the set? Is that gonna improve in any way the speed?
Let's find out. Remind me. I got require set like that, or is it a capital S?
Not sure.
All right, let me see. I can look it up here. Got some set somewhere in here. Set. Require set. There it is. Let's just borrow this and this. Okay, so let's say set1 equals set, and I don't know if we can do it this way, but let's print it out. Oh, actually, I can just return set1. Let's see what that does. No, okay, so we need to actually have a set like this and try it like this. There we go. Okay, so now we have a set. Let's give it an actual variable name.
I'm not even sure what this set is actually.
Essentially, it does the same thing as nums.unique. A set just takes the unique values. As we see, 221 becomes 21, but it is its own unique class. Instead of an array, it's a set that whittles this array down into just the unique numbers.
But it's not even included by default. You need to require it, right?
Yes. So what do we want to do with the set now?
Nothing, just like loop through it. The same thing. Can you loop through a set? I think you can, right? So you could say
so. Let's see.
Do, and then
let's just make sure this works. Now, why is that? Undefined method set one for, okay. Oh, let's try each. Okay, so yeah, we can loop through each set.
Yeah, but it's already looking like even more heavy than the unique one.
I don't know, maybe because when you say unique, it's kind of doing most of the work in the background without you knowing. So I'm not sure if this is going to be faster or if this is going to be heavier. Because we are creating a new object, but I'm not.
But how are you gonna compare uniqueness inside the set now?
Oh, the same thing, I guess.
Well, we can still compare it to nums here, similar to the way we did this.
Yeah, same
Possibly.
thing, right? Yeah. Okay, so if the same exact code you copy pasted.
Let's try. Okay, so we still get 1104. Let's
Is
take
this any better
this.
than what we had? Is it worse?
Yeah, but it's like we just wrapped more stuff around and it's gonna be heavier.
Do you need to acquire the set before pasting it?
Yeah, it's true. Yeah, I tried a lot. Okay, so it is a little bit faster. But let's see, and where's the 211 for the megabytes for memory and 213. So it's a little heavier on memory and a little bit faster in runtime.
Okay, I mean, it's expected to be heavier on memory. You're acquiring like a new library, so.
Absolutely. Yeah. But not quite as fast as we can get.
Yeah, I don't know. You got it to 64. I don't know.
Yeah, it was I tried a lot of different things here to get there and try, as you can see, I just tried different ways and different methods and ways to get it faster. I could not get the memory down too much. It's all around 211, 212. But the runtime. Any other suggestions here?
What about inject method? Maybe we can try using it.
Okay, tell me what you want me to write.
We iterate through each element, and if we don't find the match, we return it basically.
Okay. Yeah. Can you
tell
me exactly what you want me to write?
Like just iterate through nums with inject, the inject method.
Okay, nums.inject.
Yeah, and then we kind of pass two variables. One is like I'm trying to figure out. Just we need do, and like inside we basically like I'm trying to explain. I haven't worked. Okay. I've been in JavaScript for a moment now, and I am kind of forgetting about Ruby at the moment. But so basically, you go through the array, you take a number, and you compare it to the next one. And if it's not the same, if there is the same numbers inside, if the current number is unique, you basically return it.
Okay, the only thing I see with that though is you're only comparing one number to the next number in the array, and when you move on, you've left the last number behind and gone to the next two of a comparison. So it's only going to notice if two are side by side.
Okay, we could do it we could do it with an, as Zil is saying, but like with an array. So maybe like define an array called.
Yeah, but one of those variables you basically hold the unique value, like I think, or I'm not even sure. Let me see, maybe.
Okay, try defining a like an array called I don't know, something like not duplicate. I don't know.
Not people, and
it's gonna be empty, right?
Okay.
So now we're gonna go through the array. So we could use the nums.each or whatever it was, and then if the number is not inside the duplicate, if it's not inside the duplicate, we add it, and if it is, we remove it.
Okay, so let's see,
and then
not people dot
push.
Include. Well, yeah, okay, so we can push val unless people include. I get this one mixed up with JavaScript a lot. Is Ruby includes or include? I think it's includes.
I think it's included. I think.
No, I don't think this is gonna work, because if it does include it, we wanna remove it. You see, we don't just wanna push. We also wanna there's push and then there's shift. No, it's remove, right?
Well,
You see what I'm
well,
saying? If it includes it, then if it doesn't include, okay. So what are you doing? The push unless it includes it.
So,
okay, but then you need another statement that says dot remove it if it includes it.
Okay, all right. So then, not people dot. I think it's delete.
Yes. Can you just say that?
I don't know.
Okay.
If let's see what happens. We'll return not duple and see what we have in our array. Okay, so it is include with a question.
The same for the other one.
Oh yeah.
Remove the S.
Oh, thanks.
Okay.
So empty arrays.
So why is it?
So let's see what happens if we just have this line. We're just pushing. Okay, so we have
2 and 1.
A unique array now.
Okay. Dot delete value.
Now, so if it includes that, let's swap the order.
No, you see, you need an if else if statement, because now you're pushing it and then you're deleting it.
Yeah, that's why I think swapping the order might do something. Yeah. Nothing at all. All right, so let's create an if else. Let's see. Not equal dot include else and. All right, so if it includes it, if it's already there,
we remove it. If it's not, we just tell them. Yeah.
Okay, so what happens? Okay, now we have 1104. Now we need to return just that one.
Okay. Okay, that works.
Yeah. All right, let's try this. All right, so it is getting faster. Still the same memory usage, but that's okay. But we are faster here. Let's just take a quick look here. The next fastest runtime I have is this solution here. Okay, so first we're cloning. We're going through each one and we're deleting. Let's see, that was a unique.each val. Now is that deleted? What am I doing with the clone? I'm subtracting things from it. Okay. Clearly I was fooling around with this one. Let's see, yeah, that doesn't affect anything. We didn't leave that there.
So is clone it's just a variable, right? It's not something special.
No, clone is just a cloned array of our nums array that we can
but
compare.
It's just a variable. It's not like a special object. Yeah, okay.
No. Okay, so we have this. We're going through. We're deleting.
Is it necessary to clone? Because I think this could
probably
save
not.
some time.
Okay. Let's see. So we're taking. So what it looks like I've done here is I've created an array, say, of just these two, and we're deleting them from the whole clone array. Certainly not the best way to do it. The next fastest one was only 184. Huge jump. So let's take a look at what we've done here.
Well, it seems to me like I don't know. Okay, let's say a single number. Okay.
All right. So I've still cloned. I'm still looking to delete from nums each value that is that each. And then deleting everything out of nums except for the unique one.
Yeah, so you don't have the second loop anymore.
Right, that's basically all that came out.
So what was this second loop doing in the other one? What were you doing with it? And
so let's look at them side by side here. This one is the one that came out. This is just seeing.
It wasn't doing anything, right?
Yeah, this doesn't look like it's doing anything at all. Yeah, that's why it came out.
Okay. Okay.
So we're still cloning. And one thing is that I found really helps a lot of algorithms is if you have a single number in this case, or if you have the base case first, because occasionally you do run into the fact that you only have one item, go ahead and return that instead of running through the whole loop. I've got a few algorithms I've created that basically look like this. A couple of lines down to return the simplest cases if it doesn't need to actually loop over anything for just a really quick answer. That's one way to.
Can you remove the first line? Just remove the first line and and submit it as it is. Let's see.
Sure.
It changes by that much, because if you only have one number, then it's not really gonna loop, is it?
Well, if you have one number and it still has to go through the loop here, it's going to first clone, it's going to set this up, it's going to delete, it's going to still do all this, even though it's going to take less time with just one number, it's still going to run all these other lines. With this, if the length is 1, it's going to ignore all this and go straight to returning the one number. So let's take a look here. I've lost where my thing is. Here we go. This one, here we go. Okay, so the same code without that one line.
That one
now,
with
it was
180, right?
1164.
1164.
And it's down to 200 without that line.
No, it's not this one. It's not the.
Yeah, you're right. Sorry, it's this one, which was 184.
Yeah.
So it's not much of a difference, 16 milliseconds, but it's that one use case that just saved us a little bit of time because it didn't have to run the other lines.
Okay. I mean, it's not bad. It's like, 20 milliseconds?
Yeah, 16 or something like that. And yeah, 16 milliseconds. So it's not a whole lot, but keep in mind, that 16 milliseconds does add up if you do it enough times.
Yeah, absolutely.
So if we can save even 1 millisecond here or there, and depending on what other kind of algorithms you might have to do, return this if it's 1, return this if it's only 2 arrays, digits, or you might have to actually handle things differently. If you've got an array of 2 digits, it's simpler to run one algorithm versus an array of 1 million. And if you set that up ahead of time, you can already be prepared for the faster cases being handled with a different algorithm.
Okay, man, show us what we're waiting for. Show us the big one. 61 milliseconds.
The fast one, huh?
Yeah.
64 milliseconds. Here's what we did. Let's hide this one. All right. So we have a hash. I put everything into a hash and then just find the key of 1. Key with only one thing in it. Creating a hash table was the fastest way to do this.
Okay, so you're iterating through the numbers. If let's just see if count hash.
Yeah. That's really smart and very simple way, to.
So why you guys are definitely on the right track here. The one thing that was really killing the time was setting this up. And because it has to run a method and then it has to run another method. When we had the count going, wherever that is, it's running a method and it's running another method every time it runs through the loop. This takes a lot of extra time. The less methods that you're running, this is only running this one here to set up the loop, and then it's just going straight to the key.
Okay, I just want to test something. Instead of using a hash, use an array. Same method, same everything, but just instead of count hash is equal to curly brackets, make it square brackets.
The problem with that is the rest of the setup. You know, I've created a key here.
Okay, so val, right? That's just like the key.
Yeah. So what I'm doing, it's set up a first a hash.
Yes.
I've got the key, and then I'm counting for each one, and each key is that value. So 2 has its own, and it counts. And okay, so we've got 2 and 2, and then it looks for whichever key only has 1 in its value.
Yeah, that's okay. But val is they're all integers, right?
Yeah, the so key itself.
You can use an array. That's fine. The only problem is with the last one.
Value.
Yeah, you can't make a key value pair like this with
yeah.
Why not?
This is really nice. Like
well,
then you
let's
check,
just run it.
No, the last line you have to change it. At 77, yeah, there's no dot key, so
right. So how do you want to write this?
No, with array it wouldn't work.
I know, but let's listen to what his suggestion is.
So what are you outputting? Dot hash dot key 1. Why the first one? Why the second one?
What's that?
So basically, if the key already exists, you just increment it. So you know, so that's why you know that it's not unique. If there is 2. If one hash has 2 value as 2, then you know that there is 2 of the same in that array.
Okay, this line 77. What are you doing? Count hash
this
key 1. Yeah, what does that mean?
So what this does is it finds the key with this value.
Yeah.
Watch. If I change this to 2, we know that this one, the key with the value of 2 is going to be 2. So I should get the answer of, oh, oops, I need to change that back to 2. So now I get 2 because it looks for the key that has this value in it. So I want the key that has a value of only 1 because as it goes through, okay, so it says 2. 2 doesn't exist, make the value 1. Now it goes again. 2 exists, make the value, added 1 to it. 1 doesn't exist, make it 1. So it should only ever have 1 key with a value of 1.
Okay, I don't get this. What do you like? Shouldn't you be count dot value 1? Like you're getting the one that has a value of 1?
No.
Understand where you're getting the key.
Okay. The last part is bit not clear.
Let's say I have a hash like this. Okay, key 1 and value, and then I have key 2 other value. If I were to type in hash dot key value, it's going to return key 1. If I were to type in other value, it's going to find key 2 because this wants to know which key has this value.
That's okay. So the last one, the last line is actually a loop, right? It's going
yeah, I believe it would loop through.
So instead of this, can you do a loop and basically output just anything that has a value of 1? Again, put it back as an array. I just want to see like what's the difference between a hash and an array.
Okay, but we cannot make this an array or we would not have key value pairs created.
It does, because again, the value is not like, it's just a number, it's just an integer, right? So it's going to create an array and at the second position, it's going to have, for example, 0. It's going to work, it's going to work.
It's not going to work. I tell you what,
just try it.
How about I let you share and you just show me what you're doing because I don't know what you mean to do here.
Can I take
Can
I try and
I will just copy this into the Slack channel and you can set up the exact same thing I've already got.
Okay. The thing is I don't have the program open that you're using.
Oh, you can use any text editor. This is just Atom.
No, I'm saying the one that
lead code.
That's fine. Just show us what you mean and I'll copy it over and we'll work that out next. But I want to see what you're even talking about because I don't think we can make this into an array and do the same thing.
Yeah, you could do something, but you need like multi-dimensional arrays, basically. I think.
Yeah.
That would be.
Understand what? Let's just try it.
Yeah. So let's see what you mean.
Let me just open an Ubi file here. New file. I don't know. Ubi.lb or something. Yeah. So what was that? Fine. You posted it in this Slack, right? Yeah.
Yeah.
Okay. Define. Control-C. Okay.
But this count hash.key one, what if there is multiple keys, multiple values one?
We would have to write it a little bit differently, but one of the parts of this particular challenge was that only one will ever have this. If we had say, 2 1s and 2 2s and no actual answer, we'd have to write an extra letter, an extra line that just accounts for the fact that we have 2 that have the key of 1. And I don't know what would come out. I haven't tried that, but that wasn't a concern with this particular challenge. So I didn't account for it in the algorithm.
But it's really confusing.
Well, let's just try it if it works in this sense. No, it's looking just for the first one. Okay, so the same exact way that that we have set this up, instead of using a hash, we can just use an array. And I'm saying this is gonna work because, for example, let's say you have the value of 2 here, and you're saying count hash value is equal to 1, right? So here it's gonna, in the array, it's gonna have basically nil, right? And then nil, so 0, 1, and then this one is gonna set it to 2.
I see.
Yeah.
Okay.
So
we'll end up having a lot of
empty
hills.
Yes.
I mean, if my array was say 2, 300, 301,
it's gonna
have a 300 digit. Yeah, it's gonna be a huge array, but it might still work the way you're saying, and we'll see.
I just want to see like the difference. I know that the hash is much faster. I just want to see how faster. So,
absolutely.
Yeah. So here we're gonna have a count hash dot each, and then do right, same thing, and okay. So what do we want to do here? We want to see if,
instead of a loop here, though, we still have a method that will find. I mean, we can write out a loop as the long way, but we have a Ruby method, I think, that will find a value in an array, don't we?
Unique?
No. I'll look it up while you're doing this. I'll try to find it.
I mean, we could just do this. If value is equal to 1, then we could just return the value, which is if value is equal to 1. Okay, each, I think, with index, right? So with index, and instead of, we can have value and index. So if the value is equal to 1, we return the index. Yeah, this is the idea. Is this going to work? I don't know. Maybe, probably. Yeah, so this works. Same thing. So let's place this. Okay, so can you try this out and let's just see the difference?
Can I see what you did there? Or you copy it to the Slack or something?
Yeah. It's just basically a photo instead of the last thing that you did, and I'll put that.
Okay. Let's see. Go. Index minus too small for array. Okay, so let's put it in here and see what we can do to make it work.
What was the mistake? It was saying the index was too small?
Yeah.
What does that mean?
Well, it worked for these. Oh, hold on. I've added an extra number here, and I don't really know what that meant, to be honest with you. But in here, this works 1104. So let's look. Line 7, index -1, too small for minimum 0. Count hash value is 1. Well, that's weird. Oh, that's not what I want here. So that it does run in here.
Oh, so
Okay.
yeah, maybe you know the like
I think I did it.
Test L's is like one of the numbers is -1, so that's not gonna work. Yeah. Can you change the testing to not include -1s? Because of course that's not gonna work. You're saying get me the -1 array.
Yeah.
I don't know. Can you change the testing conditions of this software to not include negative numbers?
Problem is, if we have a negative number, then we still have to account for it. Like
It's
if
not
I
gonna
have
work.
2, 2 -1,
It's
then I can't
it's not
create
gonna
that.
work. Yeah. Yeah.
So aside from that, it does work, but
It takes a lot more space time.
there's something else here that I think we can try